We're asked to invert the matrix we'd have if we close this off with a bracket, but in order to inverse a matrix, we reduce it, and before we do that, we augment it, and then we reduce the augmented matrix. Okay, so what I'm going to do is okay, I don't see anything really good to do here. So what I'm going to do is I'm going to simply, now I could subtract 3 times the first row from the last, and let's go ahead and do that. That'll save us a little bit of trouble later on. Okay, first 2 rows aren't going to change, but we're going to do the third row minus 3 times the first row. So that's going to be 0, 9 minus 3 times 3, 40 minus 3 times 5 gives us negative 5, and 12 minus 3 times 5 gives us negative 3. And we get negative 3 times the first row added to this is negative 3 here. 0 is going to give us 0, and another 0. We're not going to add anything, and we're going to have a 1 here. Okay, so now we've got some progress. We've already got a 0 here. Now the next thing I do, and let's keep track of what I did negative 1 times row 1 plus row 3. Okay, next thing I did, or next thing I want to do is I'll divide through this row by 3, getting 1, 5, 5/3, 1/3, 0, 0. So that's 1/3 of row 1. And then I have my 4, 17, 5, 0, 1, 0, 0, negative 5, negative 3, negative 3, 0, 1. Now we don't do anything with the matrix on the right except whatever we do with the matrix on the left. This is the matrix we're inverting, and we have to reduce this matrix to the identity. Okay, so my next step is going to take negative 4 times the first and add it to the second. So it's going to be negative 4 times row 1 plus the second, and that's going to replace the second row. So my first row is going to stay the same. My second row, well, negative 4 times 1 is negative 4 added to 4 gives me 0, and that's exactly why I did what I did. Negative 4 times 5 is negative 20 added to 17 is negative 3. Negative 4 times 5/3 is negative 20/3. Okay, 5 is 15/3, so I think we're going to have a negative 5/3 here. Now we're going to have our 0, negative 5, negative 3, etc. And of course we're going to do negative 4 times the first row to the second all the way across. We're going to get negative 4/3, 1, 0. Okay. Then I'm going to multiply this row by negative 1/3 to get a 1 here. So I'll have 1, 5, 5/3. Now I might make a mistake here because I'm just doing this. I haven't practiced this. I haven't worked this out in advance. So if I happen to do it right, you can be impressed, but if I screw it up, don't be surprised. So we're going to have, 5 9s here, because, oops, yeah, that's right. Negative 1/3 times 5/3 is 5 9s. Negative 1/3 times 4/3 is 4 9ths. And of course we have then negative 1/3 times 1 is negative 1/3 and 0. And then in the last row we've got 0, negative 5, negative 3, negative 3, 0, 1, this row being unchanged. So what we've done is negative 1/3 times row 2. Okay? Now I've got a 1 here, so I can add negative 5 times the second row to the first, And I can also add 5 times the second row to the third. And I'm going to actually combine those. They could be done one at a time, but clearly neither of those operations would interfere with the other if we did them sequentially. So, what are we going to get? Negative 5 times this plus this is going to give us 0. Okay. Negative 5 times 5/9 is negative 25/9. And this is 15/9. So we're going to get negative 10/9. Now there are many opportunities to mess up, so again, don't be too surprised if I do. Negative 5 times 4/9 is negative 20/9. 1/3 is 3/9, so that gives us negative 17/9. And we still got, we don't have a 0 anymore because we're adding to the first row. We got to add then negative 5 times this row to this, which is going to give us 5/3. And then we're going to have our second row, which is the same as it is. Okay. Then we're going to add 5 times the first row to the third, which is going to give us a 0 down here. Now 5 times 5/9 is 25/9. Negative 3 is negative 27/9. So it looks like we've got negative 2/9 here. Okay. Now 5 times 4/9 is 20/9. Negative 3 is negative 27/9. So it looks like now we've got negative 7/9 here. And 5 times negative 1/3 is negative 5/3. Added to 0 is going to be negative 5/3. And then we're still going to have our 1. So what this is, and you're probably standing in the way, let's see if I can move back a little bit. This is row 1 minus 5 times row 2, and this is row 3 plus 5 times row 2. Okay. Now we need to get a 1 here. And we need to do that before we do anything else, because once we get our 1 here, we're going to use it to wipe out these numbers. Okay, so we're going to get a 0, 0, 1, and of course these top 2 rows are still going to remain what they are, negative 17/9, 5/3, 0, 4/9, negative 1/3, 0. And what are we going to do to get a 1 here? We're going to take row 3 and multiply it by negative 9/2. Okay, so negative 9/2 of negative 7/9 is, well, the 9's kind of divide out, we end up with 7/2. Negative 9/2 of negative 5/3, we're going to have, and I want to be careful doing this in my head, it's going to be positive. 3 will divide the 9, giving us 3. So that'll give us 15 halves. And negative 9/2. And let me just kind of double check that. Yeah, that works. That works. I think that's possibly right. Okay, well now, what I've got to do is add 5/9, subtract 5/9 of the third row from the second, and add 10/9 of the third row to the first. So this is going to be row 1 plus 10/9 of row 3. This is going to be, well, row 3 is going to stay the same. This is going to be row 2 minus 5/9 of row 3. Okay? And that's going to give you 1, 0, 0, 0, 1, 0, 0, 0, 1, and whatever you get over here. And I'm not going to actually do it, because I probably made a mistake at some point anyway, but that would complete the inverse process, and this now is your inverse matrix. So if we call this matrix the A matrix, this matrix is the identity matrix. So you got the A matrix augmented by the identity matrix. When we get down here, we have here the identity matrix, and we have A inverse. Then we can check this, because if you multiply A inverse times A, it should equal the identity matrix. So you check this and see whether it's so.